This is the last lesson of the solar system portion, and it's titled "How Do the Sun, Earth, and the Moon Move?" As you can see with my little GIF here, it's just they move basically as a unit. Each one of them has a job, and they do it. So we're going to learn more about that movement and how that movement affects us on Earth and different things. Okay, very different orbs. There are millions of kilometers or millions of miles between the Earth, the Sun, the Moon, but yet we feel the heat from the Sun and we see the whitish part of the Moon. These are direct evidence that these bodies, the Sun and the Moon, are different from our planet. So we can feel the heat from the Sun and we can see the light side of the Moon. Okay, so we can tell that that's very different from what we do on Earth. Now, here are just some characteristics. If you want to, I'm not going to read all of it, but if you want to pause the video and read about it, you can. But basically, the Earth is a planet. The Sun is a giant ball of gas that creates energy that then creates heat and light. And then the Moon is visible from Earth, and it's the Earth's satellite, and it reflects the Sun's light, which we see. That's how we get to see the moon phases. Okay, the Sun, Earth, Moon system. A year in time on Earth, okay, 1 year is the length of time it takes for the Earth to revolve around the Sun. Okay, one more time. A year is the length of time it takes for our Earth to revolve, which means to go around the Sun. Okay? Now, any object that revolves around another object in space is called a satellite. Okay, if we use that logic, that means that Earth is a satellite to the Sun, which makes the Moon a satellite to Earth. So anything that revolves around something else is called a satellite. Now remember, it takes 365 and 1/4 days for the Earth to revolve around the Sun. Now this year, 2020, we're actually going to have 366 days because if you do the math, that 1/4 every 4 years, we pick up an extra day. So that's why we have leap years, and this year just happened to be a leap year. And the Moon, it only takes 27 Earth days for it to revolve around the Sun. So when we talk about the moon phases, you're going to see that the lunar calendar is a 27-day calendar. So that's how we get the 27 days. Now the path that any satellite or anything takes, okay, in space is called an orbit. The Earth orbits around the Sun, and the Moon orbits around Earth. Now, what keeps everything in place? What keeps everything orbiting? Like what makes the Earth orbit the Sun? It's gravity. The Sun's gravitational pull is keeping Earth in its place. And what's keeping the Moon in its place? Well, it's stuck in the Earth's gravitational pull. Now, gravity is a force of attraction. Like if I were to drop this pen, it's going to fall down. That's gravity. Gravity is pushing the pen down. And it's attracted to the ground. Also, gravitational attraction depends on two things: the distance between two objects and the mass of the object. Now, like I said earlier, we talked about this a while back. Gravitational attraction, the closer two objects are, like if I were to take magnets, okay, and if I put them close together, they're going to go together. So if the gravitational distance, the distance between the two things are not great, okay, then that gravitational attraction is going to be really strong. Also, if you have larger mass, the larger the object, the greater the gravitational pull. So, of course, the Sun, being a giant star, has a lot of pull because it goes all the way out to Neptune to keep it in its gravitational pull, to keep it orbiting the Sun. So that has a great deal of gravitational attraction. whereas Earth doesn't have that strong. Okay? So gravitational attraction depends on size and distance. Now, as you can see in the top right here, orbit, the Earth revolves around the sun in a counterclockwise. When you see a clock, okay, it goes from, I'm trying to see if I can do this, come to think. Okay, so it would go like this. So like here's 12 o'clock, 1, 2, 3, 4, 5. So the clock would go in this direction. Okay, counterclockwise would be going from 12, 11, 10. So the Earth rotates in a counterclockwise direction. The moon also revolves around the Earth in a counterclockwise position. The Earth's orbit around the sun is nearly a circular shape with the sun in the center. So as you can see right here, this is the Earth, and it revolves with the red line. You can see the red line like this right here. Okay, but it's not, so it's going to go counterclockwise, just like that. Okay, the moon, its little orbit goes like this, counterclockwise. Okay, now gravitational pull, here's the sun, right here, the gravitational pull it has, okay? The sun is 330,000 times more massive than Earth. Its strong gravitational pull keeps all objects near it from flying off into space. Gravity also keeps the moon in its orbit around the Earth. Gravitational pull decreases with distance. So here's the sun, here's our Earth. So the gravitational pull is basically keeping Earth going in an orbit instead of just shooting out. It's kind of like if you were to, like when we were little, we used to tie, like to a string or whatever, a ball, and we would spin round and round and round and round, and then let go of it, and it would just shoot out. So that's basically what we're doing. If you were to take that string and the ball and spin in a circle, you would be the sun, and your force with that string is keeping that ball in an orbit. But as soon as you let go, like if the gravitational attraction just disappeared, that ball shoots out. So think of it like that. The sun is keeping the Earth on track. If that gravitational force goes away, or attraction, we're just going to go shooting somewhere into space. That's not good. So we need the gravitational attraction. Gravitational attraction is a good thing. Now, enough with attraction. Let's talk about eclipses. A few years ago, we had that opportunity to see a complete solar eclipse, and it was weird, to be honest. But an eclipse is an event during which one object in space casts a shadow over another object. We experience two types of eclipses on Earth. You have a lunar eclipse, and then we have what's called a solar eclipse. All right, now, a lunar eclipse. A lunar eclipse is an event so it has to be a full moon, when the moon moves into Earth's shadow. Okay, Earth's shadow, or any shadow, has two parts. The umbra, which is the darkest shadow, and the penumbra, which is the lighter and the whiter part. So the main part is right here, which is the umbra, right here. Okay, and the pre is up here, like the lighter shades. But anyway, what happens with a lunar eclipse is basically you have the sun, then you have Earth, and the moon. So for a lunar eclipse, the Earth is in between the sun and the moon. Okay, right there. So basically what's happening is the Earth is blocking the sun from getting to the moon so we can see the full moon. Okay, so same thing here. You have the sun shining directly. Okay, the sun is shining, and the Earth is in the middle. Okay, and basically it's like darkening out the moon, so the moon can't get any light, so the light can't reflect, and we can't see the moon. Now, it's like this. This is a little video. The sun is shining, the Earth is in the middle, and all the sun is being blocked. All that light is being blocked from reaching the moon so we could see it. We can't see it. It's kind of like if someone were to stand with a flashlight and you were on the other side and you see that light's hitting you full on, If I were to step in front of you, the light couldn't hit you. So that would be like a lunar eclipse. Now, a solar eclipse is just the opposite. It's an event during a new moon when the Earth moves into the moon's shadow. During a solar eclipse, the moon comes between the Earth and the sun. And just like before, there are two parts of the shadow: the umbra, which is the darkest part, and the penumbra, which is the two parts, the lighter part, but it's wider. So, like in the picture, instead of the Earth being in the middle, the moon's in the middle. The sun, the moon, and Earth. The moon is basically blocking the sun's light from reaching Earth. It doesn't last very long, but you still get to see the sun being blocked just a little bit in the shadow. Now, the sun is not smaller. It's kind of like, have you ever looked at a house far off and put your thumb up and your thumb completely covers the house? It's kind of like that. That's how the distance thing is. The sun is far, far back, and the moon is just moving, and it blocks it for a second, and then it goes away. That's how it is. The moon just didn't all of a sudden get large. It's just that the sun is so far away, and the moon just moves in the right place, and you can cover it up. So that is your solar and lunar eclipses. So you can see right here. And when you have a solar eclipse, not the whole Earth can see it. It just, they go in a path. And if you happen to be along that path, you get to see the solar eclipse. Other parts of the world, it doesn't really affect. They don't get to see it because we're not on that path. So not everybody gets to see a solar eclipse all at one time. Now, here's just a poster. You can pause this and look at it a little more in depth of a total solar and a lunar eclipse. Now, why they call it a total solar eclipse is because the moon completely covers the sun. You have sometimes where it goes like a little bit, but this one's a total lunar eclipse. Okay. Clear as day and night. Okay, day and night, something that happens every day. Each morning, if you look in the east, you're going to see the sunrise. Okay. At first, you think that the sun is low in the sky. And as the day moves on, it's kind of the sun, you think the sun's moving. Okay? You think, okay, the sun's moving across the sky and it's going to set in the west. Okay? The thing is, the sun is not actually moving. It's stationary. Okay? It doesn't revolve. It doesn't, it stays there. Instead, the earth is actually rotating. Okay? And this spin allows for the sun to appear to be moving. And that's what makes night and day. That's what makes night and day. Now, just like we talked about earlier, our Earth is tilted. Okay, and that's going to come in handy when we start talking about seasons. But our Earth is tilted. And as you can see on the picture, here's the sun. When it's daytime on one side of the planet, it's nighttime on the other. You can't be day on the sun on Earth all the way around Earth. Okay, it can't happen because there's only one sun. It's in one location. So when it's daytime here in America, on the other side of the globe, in Europe, parts of Africa, it is nighttime. Okay, that's also why we have different time zones. That's why some countries are hours ahead of us, like Europe or England is 8 to 9 hours ahead of us. It just depends on what their time zone is. So when it's daytime on one side, it's nighttime on the other. Now, what exactly is an axis? And we talked about this earlier. An axis is basically a measuring line that goes through an object. It's like poles. It's kind of like if you were to have a toothpick and stick something through the toothpick, okay, like a grape, okay? You would have, the axis would be the 2 points, okay, of the toothpick. So that's kind of like what the world or our Earth is. It has 2 poles. You have the North and South Pole. Okay, these are our axes. Okay, our axis is tilted at a 23.5 degree angle. Okay, this rotation on our axis gives us the appearance that the the sun, the moon, and the stars are all moving, where in reality we're moving. We're not moving very fast, or we could feel it, but the Earth is moving at a speed that we can't feel. So what happens is because the Earth's movement, okay, and the moon and everything else is staying in that position, it gives the appearance of actual movement. Okay, now here's some more information on the Earth-Sun interaction. The Earth's rotation around its axis causes night and day, but what actually causes the seasons to change? Well, the answer is the revolution of the Earth around the sun. We have 4 seasons. Here in the South, it basically feels like we have 2 and 2 more that are really, really short and sweet. But you have 4 seasons. And the reasons for the seasons, you have, I start with winter because it's January. Winter, spring, fall. Well, I skipped summer. Winter, spring, summer, fall. Those are your 4 seasons. And the reason we have that is because the Earth is tilted and that it is moving around the sun. Now look at the picture on the right. Notice that the Earth's axis is not straight up. It's kind of like if I were to take a little pear right here. It's not standing straight up. It's tilted. Okay? Now it's at a 23.5 degree tilt. So it's this tilt and how the planet is moving, okay, actually causes our seasons. So if we look right here, okay, the Earth is tilted at a 23, like put 4, but we just did 5. We have 4 seasons, okay? Now, we also have something that's called a winter and summer solstice and a spring and fall equinox. That's something you're going to learn next year in science. But anyway, when you're in the summer, the tilt, that part of the globe is at the closest point to the sun. Now, as it revolves, the same point in September, you're further away from the sun's tilt. So that means it's going to cool off a little bit. And then in the winter time, that's your furthest away from the sun you're going to be. And then in the springtime, you're coming around back into the sun's heat. So that's why we have seasons. Now, like I said, seasons are short-term changes in climate. There are 4: winter, spring, summer, and fall. The seasons happen because our Earth is exposed to different amounts of light. In the summer, you are exposed to the most. You're closest to the sun because of the tilt. So when fall comes around, we're moving just a little bit out of the sun's range, okay? We're moving out of the sun's exposure. When winter comes around, we're not exposed to a lot of sun. We're the furthest away from the sun. When spring comes around, we're moving back into the sun's appearance. So those are your seasons. Now, the next thing is moon phases. Now, I haven't taught moon phases in quite a while because it was a 6th grade standard and not a 5th grade standard. But one night, when you look at the moon may look like a tiny sliver in the night sky. And the next time, it may be a bright circle. Why is that? Because we have moon phases. Because of the shadows that are being cast during that moon cycle. Okay? So as the Earth orbits the sun, the moon also orbits Earth. The moon reflects the amount of light that's given to the sun. That is the light we see from Earth. Okay, that's like the reflection. It's reflecting the light back. As the moon travels in its orbit, different amounts of the moon's lit side can be seen from Earth. The moon's shape actually doesn't change. The moon stays round. Okay? The change in the appearance is actually a shadow that's being cast, which is called a moon phase. And like I said earlier, a lunar cycle is 27 days. And the moon, like we said, the moon revolves around the Earth in a counterclockwise position. So the counterclockwise position makes it so that it's going to move, like I see in the picture right here, in this direction. So the first phase sorry, my nose is itching, in a lunar calendar is right here, the new moon. Okay? A new moon is just basically where you see very little of the moon, okay? Because it's actually, the sun would be on this side and it's being cast, a full shadow is being cast by Earth. It's not an eclipse, it's just a shadow. So after a new moon, you have your waxing crescent, and it's called a crescent because it actually looks like a crescent roll. Okay, some people even call it a God's thumbnail. Just depends on how you're looking at it. So you have a waxing crescent, then you have a first quarter. Okay, after the first quarter, you have a waxing gibbous. So your waxings are your first part of the moon phases. Now we have a full moon, which means the moon is completely lit up. We can see it. Okay, now as we go from the full moon, we're losing the moon again. You have your waning gibbous, which means this side is darkened. Your third quarter, which is right here, as you can see right here, it's kind of opposite of that. And then your last phase is your waxing crescent. Now, if you can look over here, I did some new moon in yellow, first quarter, full moon, last quarter. I did that in yellow because those are the four main ones. Okay, you have your new moon, your first quarter, your full moon, and your third quarter. Those are the four main ones. Okay, then in between we have our waxing crescent, waxing crescent, waxing gibbous, your waning gibbous, and your crescents. Okay, so these are your moon phases. You can take some time right now and stop the video, watch it, and see what you can get. Now, patterns in the sky. I'm not going to spend a lot of time on constellations, but anyway, patterns in the sky. You know what the Big Dipper is? The Big Dipper is a actual star pattern that the ancient Greeks used to refer to as the giant bear because it's inside of a pattern that they would make the bears. Now, star patterns are called constellations. Now, a constellation is a group of stars that forms a pattern or a picture in the night sky. And the early Greeks actually had myths about these stars and how different things came about. When you get up into high school, you'll learn how the Greeks used these stars to tell stories and how some of the Greek mythology has a great deal of information with the stars. So the Greeks were one of our first astronomers to be doing all this stuff. But constellations, there's a lot of them. And actually, you don't see the same constellations all year. As we talked about, we're rotating and revolving, which means our stars stay the same, but we move. We get to see different parts of the sky. So that's always a good thing to do. And if you ever want to look some more stuff up, you can look at constellations. There's millions of constellations out there, different ones. I can personally say that I was never good at finding them, but there's some people who are. But anyway, that is lesson 3. I hope it was okay. I'd much rather be doing it in person with you, but we can't. If you want to, there's a lesson 3 quiz over on Google Classroom. I just hope everyone's doing okay, and I hope to get to see you soon. And I hope everyone is just having a good time and just stay out of trouble. All right, I'll talk to you.